So this is going to be the intro to Unit 6, Lesson 2 for Radians. I just wanted to just start here, and kind of instead of doing their exploration, I just wanted to kind of give a general understanding of radians before we get started. So radians is the ratio. It's defined as the radian measures the ratio that compares the length of an arc to a circle radius of the circle. So the length of the arc compared to the radius. And so it's written in a kind of almost like a length rather than degrees. And so the important thing to understand with the radians is that they're really not too bad. And this is where I told you if you're good with fractions, you're going to probably be fine with this. But we know that, if we just do the simple, we know that degrees is 0 to 360. And we can just cut this circle into the places of where, the different cuts are. I'm not going to go too much into the unit circles. We have a lesson on that coming up. But, they do a 30, 45, and a 60 cut is kind of how it's cut up. And then to 90. And it keeps having that same slice through all sections. Again, I'm not going to go into that because we'll hit that more with the unit circles. But the point is that radian, since it's now talking about a length, an arc length, it's important to understand that this circle, okay, has a circumference, okay, and that's a length. Well, the entire length of this circle is going to be 2 pi r, because why? That's circumference formula. So 2 pi times the radius will be the circumference of this circle. Generally speaking, I just told you that radians is the arc length compared to the radius. So really, for us, it's 2 pi over r, which is kind of silly, because you see the r's cancel. Well, since the r's cancel, what I'm trying to get at is that demonstrates the length that we're going to use for radians in terms of measure. So how we go 0 to 360 for degrees, we go 0 to 2 pi for radians. And this is where the fractions come into play. Okay, so let me say that again. Circumference of a circle is 2 pi r. We are told that radian measures the comparison of arc length, which in this case is the circle length, circumference, compared to the radius. Well, if we compare them, the radius cancel, so simply the radian measure is demonstrated from 0 to 2 pi. Well, how does that help us in terms of radian? Well, what it does is now we're going to go and do all the spots, even the ones in the unit circle for right now. Maybe we won't. Well, let's just see here. So the key ones, let's go with the easy ones. 0 to 2 pi is all the way around, so then what's halfway around? Halfway around is pi, right? If it's 0 to 2 pi all the way around, halfway around is 1 pi. So then you can just kind of count. If I go 1 pi, 2 pi to finish. Okay? Well, then what's halfway between 0 and pi? Well, up here at 90 is pi over 2. Okay? What's halfway between 1 and 2? Well, 1.5 or 3 pi over 2. So these are kind of your main radian measures for the unit circle. So I'm just kind of using the unit circle to explain how radian measure works out. And so as we go through this, and we can just do a couple more of these. I'll just do the 45s. We'll save the 3060s for the unit circle. But halfway between 0 and 1 over 2 is 1 over 4, or pi over 4, right? So that if I do with the 45 cut over here, halfway between 1/2 and 1 is 3 pi over 4, like 3/4. Halfway between 1 and 3 over 2 is 5 pi over 4. And then halfway between 3 pi over 2 and 2 is 7 pi over 4. Okay? So the whole point here was just to show you the comparison of degrees is 0 to 360, radians is 0 to 2 pi. And so we use that to help us with in terms of lengths. Okay? It's a different way of demonstrating the distance around the circle. But anyways, so I just wanted to open up with that before we get to the notes. And so now we're going to click the notes, and I'm going to go ahead and go through this part 1, and we'll start filling in stuff here for part 2. So since an angle be measured degrees or radians, it says it's important to be able to convert from one measure to the other. Consider a circle with a radius r units. Complete the following. 1 complete rotation in degrees. We know that's the one we did last class, 360. So we got 360 is the 1 complete rotation degrees. Arc length of 1 complete rotation is 2 pi r. That's what I was telling you. That's the circumference, which is the circumference. I just said that. of the circle. The ratio is arc length over radius. So then in this case, is what I've shown you again, 2 pi over r, 2 pi r over r. So therefore, to simplify, then simply 360 equals 2 pi in radians. So 360 is 2 pi in radians. So all the way around is 360, all the way around is 2 pi in radians. So 1/2 of the rotation in degrees, so half of 360 is 180. So they're kind of just piecing together stuff I just wrote for you on the starter here. The arc length for 1/2 the rotation is pi, so pi r. So instead of 2 pi r, half of 2 pi r is just pi r. And so then when we set it up again, we have pi r over r, so the r's cancel. So 180 is pi in radians. Okay, so we're just getting the idea of radians. Okay, so let's go ahead and keep going on these. Okay, so pi radians equals 180. So 1 radian, like if I wanted to solve for that, 1 radian then is 180 over pi is the conversion. So then 1 degree is the flip, pi over 180. So if I'm trying to take a degree and convert it to radians, okay, I'm going to go ahead and multiply it by the, that's the conversion is pi over 180. Okay, to convert from radians to degrees, got ahead of myself again. So to convert from radians to degrees, you multiply by 180 over pi. To convert from degrees to radians, you multiply by pi over 180. Okay, so what I kind of point out to people is that we know that radians is in terms of pi, right? So if I'm going from radian to degrees, notice if I said I had, let's say you have 3/2 pi. If I multiply that over here, the pi's will cancel. If the pi's cancel, you get a degree measure. Okay, now over here, if you were confused and weren't sure what you're supposed to do, well, we're going degree to radians, so we expect a pi to stay in here. So like if I was converting 60 degrees to radians, I would times it like that, 60 times pi over 180, and you'll see the pi doesn't cancel. So that means you are in radians. The pi is kind of the indicator for me when I'm doing these. It's like, oh, okay, I'm in radians. I still have a pi left. And if I do it this way, oh, pi's cancel. I'm in degrees now. Okay, so that can be kind of your indicator of if you get lost in which one you're converting. Okay, or if you forget which one to use. Okay, so then here it is again. Pi radians is equal to 180 degrees. Degrees to radians multiplied by pi over 180. Radians to degrees multiplied by 180 over pi. All right, let's do a couple of these here. Convert these degrees to radians. So we're doing 270 to radians. Okay, so we're going to multiply it by, give you a second to answer. Okay, good. Pi over 180. And so what you have is you're going to simplify essentially 270 over 180. 270 180 simplifies to 3 over 2. So this is 3 pi over 2 for radians. And the kind of thing, again, I'm getting ahead of myself here because it has to do with the unit circle, but I know 3 pi over 2 is down here. Remember, it's between 1 and 2. Okay, so just something to think about. 3 pi over 2 radians. Just getting used to these values. Okay, so 315, convert that to radians. So times that by pi over 180. When you simplify 315 over 180 in terms of the fraction, it simplifies to 7 pi over 4. Okay. And you can do that with your calculator if you're really good with your simplifying. You can find the number that simplifies into it. Okay. Convert the following from degrees to radians. Now we're going degrees to radians. Okay, so same thing we just did. Oh, so this one's the exact value above. This one says to the nearest tenth. Okay, gotcha. So now they actually want us to not, we're actually going to divide the number in terms of fraction. So here they just, this is 3 over 2. So for this section, we write 1.5. Here is 1.75, so we'd write 1.75 for this second section. Second section actually wants you to convert it to the nearest tenth. So 70 times, same step, same work. Okay, 70 over 180 is 7 over 18 pi, and so we just go ahead and figure out what is 7 over 18, and that goes ahead and converts to 1.2 radians after we multiply it to pi. So 7 over 18 times pi is 1.2. So that means 1.2 radians. Okay, 205, so 205 times pi over 180. Okay, so that simplifies. If we want to simplify it, you guess you don't even have to simplify it. You can actually just do the multiplication. So in your calculator, you can just do 205 times pi, and then divide that by 180, and it gives you the radian measure of 3.6. Okay. All right. Now we're going to go convert the following from radians to degrees. All right. So to convert from radians to degrees, then we're going to go 180 over pi. And so as I was telling you, see the pi's are going to cancel. So essentially it's 180 divided by 4 here. So 180 divided by 4, that's going to give me 45. So I'm going to get 45 degrees is pi over 4 in degree measure. Now here's the cool thing that I really like about trig. So when I told you back at the beginning, remember I said the 45 degree cut was halfway between pi over 2 and 0, which is pi over 4. Okay, so it's kind of full circle. They always match up like they're supposed to. Okay, negative 7 pi over 3. So we're doing that. So we're going to times that by 180 over pi. Again, the pi's cancel. So that's actually going to be negative 7 times 60. 60, so negative 420. Negative 420 degrees. Okay, they said you can leave like that for now. Okay. All right, then we're going to convert from radians to degrees. Okay, so now they're giving the answer in radians. All right, that's cool. So what we're going to do now is we're going to go 1.57 radians. And so instead of giving it as a radian measure, they say the decimal, which is fine. So we're just going to go and times that by 180 over pi still, because we're still going from radians to degrees, so we still use that same formula. Okay, so we simply just multiply this now. When you multiply that out, it's going to give you 90. Okay, we got negative 1.4. So we go negative 1.4 times 180 over pi. Okay, and that equals negative 80.2 degrees. Okay. Okay, so the coterminal angles and reference angles in radians. So just doing the same thing we've been doing before, but we're into radians. So we're going to fill in the blanks of statements and the table below. Okay. All right, so since coterminal angles are angles with the same terminal arm, they are separated by a multiple of 360 or 2 pi. So 2 pi is our new 360 for today, all the way around. The principal angle of the set coterminal angle is the smallest positive rotational angle with the same terminal arms. The principal angle is between 0 and 360 or 0 and 2 pi. That's our radian range. And so it says a reference angle is the acute angle formed between the terminal and the rotation. So the relationship between the rotation angle and reference angle in each quadrant is given in the table below. So in quadrant 1, the reference angle, okay, we know that equals the reference angle. So this is a little review from yesterday. Table 2, 180 minus the reference angle. So in terms of the radians, so what's 180 in radians? Well, that's pi. So pi minus the reference angle. Then 180 plus the reference angle, so that's pi plus the reference angle for quadrant 3. And then lastly here, the quadrant 4, 360 minus that reference angle. So remember, 360 in radians is 2 pi. So minus the reference. Okay. All right. So just got a couple more here. So make some more examples. A lot of examples in this section, which is good. Help you guys get used to those fractions. Okay, so in each of the following, draw the angle theta in standard position, state the principal angle, determine one positive, one negative coterminal angle for angle theta, and write an expression involving the principal angle represents all angles in the domain. So like we did yesterday with the n can be integers, so NEI. Okay, all right, so 3 pi over 4. So where's 3 pi over 4? So 3 pi over 4, okay. Now, if you need to convert to degrees to see it, I guess you can, but we kind of got to understand that, well, 3 pi over 4 means 3/4. Well, if this is 0 and this is pi, 3 pi over 4 is right here, because we know this is pi over 2 from the intro, right? So 3 pi over 4 is right here, okay. And then it says draw the angle theta. So angle theta, that's this angle here. State the principal angle. So we're going to state the principal angle. We are going to go ahead and the principal angle for this one. I think the principal angle is 3 pi over 4 because we're staying in radians, but just in case they want degrees, that's going to be 135 per degrees if you want to know. But 3 pi over 4 is the radian measure. Okay, but I'd just like to show you the comparison. So that's part 2. Okay, part 3, determine one positive and one negative coterminal angle for the angle theta. So one positive, well, they don't want you to use 3 pi over 4 again, so I'm going to go 3 pi over 4 plus 2 pi, which gives me 11 pi over 4. Okay, where do I get the 11? Well, 2 is 8 over 4, so 8 plus 3. Okay, that's what I'm talking about, the fraction stuff. If I want a negative 1, I'm going to go 3 pi over 4 minus 2 pi. Okay, and that's going to be, this time it's going to be minus 8 pi over 4, so it's negative 5 pi over 4 is a negative one. So that's part 3. Okay, and then part 4, it wants me to write the expression for the principal angle that represents all angles. So it would be 3 pi over 4 plus 2 pi n when n is all integers. Okay. All right. Part B, negative pi over 3. So negative pi over 3 is going to be right here. Okay, I'm going back this direction. Okay. Part 2, so state the principal angle. So to state the principal angle, just like we did yesterday, we added 360. We're going to add, since it's negative pi over 3, we're going to add 2 pi to that. So 2 pi in terms of thirds would be 6 over 3. So if I add that, I'm going to get 5 pi over 3. So 5 pi over 3 is the principal angle in radians. Okay, so then it says for part 3, state your positive and negative. So we just did the 5 pi over 3, that's the positive. The positive is 5 pi over 3. The negative is negative pi over 3, but they want us to get a different one. So this one's negative if I subtract negative 2 pi over 3. So it'll be, sorry, negative 2 pi, which is 6 pi over 3. So negative 1 minus 6, so the negative one that we could give that's different is negative 7 pi over 3. And yes, that's one that goes all the way around and a little bit more. Okay. Part 4, the expression they want, it's going to be 5 pi over 3. Yeah, just want to write it a little bit different. Let's make that a little cleaner. Okay, so we want 5 pi over 3 plus 2 pi n, and then n is all integers. Okay. All right. Okay, we're just going to do one more example, and we're talking about arc length real quick. Okay, one more set of examples. Okay, so determine the reference angle for the following rotation angles. So we're trying to find the reference angle here. Okay, so we got to use those same rules that we kind of talked about within the quadrants. So it's really helpful to know which quadrants you're in. So like, for example, when I look at this first one, 4 pi over 3, that's bigger than 1. So bigger than 1 and slightly bigger than 1. So I'm feeling like, here's pi, I feel like I'm over here. Okay, I'm in that section there. Okay, it's a little bit sharper. I think it's actually going to be a little bit more over here. Okay, but the point is, I'm in the third quadrant. So that means if I'm in the third quadrant, I want to go 4 pi over 3 minus pi. Because I'm minusing this piece, right? I'm minusing the 180 to get the reference from like yesterday. So then if I'm doing that, that means if we get a common denominator, 4 pi over 3 minus 3 pi over 3 gets me 1 pi over 3. So pi over 3 is the reference angle for the first one. Okay. Now we have negative 5 pi over 4. So negative 5 pi over 4, just kind of think about it. Negative 5 pi over 4, that's a little bit, we're going negative, and it's a little bit more than 1. It's going to be right here. It's right at the top there. Okay, so what that means, okay, we're going to go the same system. We're going to go negative pi minus negative 5 pi over 4, because we're just doing the opposite. So the other thing you can do too is, well, I guess it's the same, but they write it as negative pi, because you're just going the negative pi direction, minus a negative 5 pi over 4. So it's like we're flipping what we just did for the last one. We did positive pi, but this time we're going the negative pi direction. And to be honest, some of these, well, actually, I'll just show you this way. I don't really like dealing with the negative. Let's get away from the negatives. Let me spin this a little differently. Okay, what I would do right now, I'd add this to 2 pi to figure out what the positive piece is. So if I add that to 2 pi, which is going to be 8 pi over 4, that gets me 3 pi over 4. So 3 pi over 4 is a positive, and it's right here. So it's the same spot. I found the positive coterminal angle. And so what I did that for, just because it makes it a little easier, because now you see it's pi minus 3 pi over 4. So I'm going to go pi minus 3 pi over 4. Okay, well, pi would be 4 pi over 4. So I get 4 minus 3. I get pi over 4 is my reference angle. It's a little bit easier way to do those double negatives like the book was trying to show you. Let's go ahead and switch to positive. Okay, 23 pi over 6. Okay, so 23 pi over 6, we need to get that. That's bigger than 2 pi, because 23 over 6 is bigger than 2. So we need to subtract 2 pi's until we get into our normal range of 0 to 2 pi. So if I do this here, 2 pi, if I write that in terms of 6 for common denominator, so here, show you one time, times 6 times 6. So 23 pi over 6 minus 12 pi over 6 gives me 13 pi over 6. Nope, 11. My bad. 11. And now, I'm glad it's 11, because now I'm 11 pi over 6, that's smaller than 2 pi. So 11 pi over 6 is the one we're going to use. 11 pi over 6 is right here. It's just the sliver right at the end before we're at 2 pi. It's right there. So we're trying to find this reference angle. So we're going to do 2 pi minus 11 pi over 6. Looking at that chart we just did, if you're wondering where I'm getting all these conversions, it's at the chart we just did in the previous page. So 2 pi is going to be 12 pi over 6 minus 11 pi over 6, 4 pi over 6. So our reference angle is pi over 6. Okay. So for example, we know these are supposed to be acute angles, right? And so acute angles were between 0 and 90 degrees, we said, right? Well, remember, for radians, 0 to 90 degrees is 0 to pi over 2. Notice how all of our answers were pi over 2 or less. Okay, so we have pi over 3, pi over 4, pi over 6. So those are all less than pi over 2. Okay, so now we're going to go ahead and talk about arc length. So earlier we learned that we defined the radian measure of an angle theta as radian measure as length of an arc forming the angle over the length of the radius equals arc length over radius. So in other words, theta equals a over r, so the measure over arc length over radius. So we can rearrange the formula of theta equals a over r in the terms of arc length, so solve for a, by simply multiplying the r over. And so that gives us this right here, a equals r theta. So theta is the measure of angles in radians, and a is the length of the arc around the angle, and r is the length of the radius. This formula can be used to solve problems involving arc lengths, radius, and central angle provided in measure in radians. So that's just kind of where we're going. Got a couple application problems now. So a pendulum 30 centimeter long swings through an arc of 45 centimeters. So what that means is you have this pendulum that's, it's doing a motion like this, an arc. This is the 45, it's swinging. And the pendulum is not two pieces, it's swinging from here to here. Okay, so but that length of that pendulum they say is 30. And that's going to be what in this example? So let me take a step back here. Remember, we're trying to figure out A and R is. Okay, yeah, so it's going to be the radius. So 30 is the radius. If you can kind of see it, this is the point of the center right here, right? So this length right here, that's the radius coming down to the arc length. And here's your arc length. Okay, the arc length is 45, so that's your A. So then in this example, we know that A equals R theta from just previously. So then that means that 45 equals 30 theta. And notice it's asking us to solve what angle. So we're solving for theta. That represents the angle. So we feel good about how we're setting this up. So we divide the 30 over. And that gets us 1.5 radians. Okay, because we're in radians. But it also wants degrees. So what do we do now? Well, to do degrees, we have to convert. Don't forget, at the very beginning of the lesson, 1.5 times the 180 over pi. And I know the pi is not here, but it's within that calculation. So you can, essentially you can leave it there. So it's going to be, when you multiply these, you're going to get 85.9, because you just divide the pi. So you go 1.5 times 180, divide by pi, 3.14, you're going to get 85.9 degrees. Essentially what it's saying is, that's how far, that's the angle which it's swinging back and forth. So it's covering 85.9 degrees of a swing, back and forth. Okay? So calculate the arc length to the nearest tenth of a meter of a sector of a circle with a diameter 9.2 if the sector of the angle is 150. So this is an example where we're given the angle this time, and we're given something else, either A or R maybe. And so, but if I sure know that I'm given theta. Theta is 150 in regards to, again, when we're looking at A equals R theta, we know what theta is. It's 150. Okay, so we're going to go ahead and convert the 150, though, to radians so that we can use this formula, because this formula, it's going to be in radians, not degrees. That is a common mistake. Okay, so 150, we're going to convert to radians real quick. So it's going to be pi over 180, which gives me 5 pi over 6. So 5 pi over 6 is the theta we're going to use. Ugh, that was real bad. Okay, let's rewrite this a little bit here. So theta equals 150. 5 pi over 6 is the radian measure for theta that we're going to use. Okay? And so from here, we see that it tells us the diameter. Well, diameter is obviously going to be double the radius. So we're just going to take the 9.2, divide that by 2 to get 4.6 for the radius. So now we have R and theta. So now we're ready. We're going to go 5 pi over 6 times 4.6 is going to give us A, arc length. And it gives us 12 meters. Okay. Now again, the reason, if you're saying, well, why do we have to use radian measure? Because radian measure is a comparison of the lengths, the arc lengths. If you're talking about lengths around the circle, we want to be in radian. Talking about degree, degree is not going to be in relationship to the arc length. That's a measurement of the degree turn, which is almost like a different unit. So we can't use 150 degrees in here, because obviously you'll get much different, you get something different in terms of your answer. Now your calculator does have degree versus radian mode, so you could use that. But if you're just doing standard calculations, you're going to want to be in radian mode when it comes to arc lengths. Okay, all right. Example 9, last one. Okay, a circle with a center C and a minor arc AB measuring 15.2, is shown. If angle ABC, angle BAC equals pi over 6 radians, find the length of the radius of the circle to the nearest tenth of a centimeter. Okay, so what that means is, so angle ABC, okay, ABC is pi over 6, and BAC, okay, so these ends are the same length of pi over 6, what it's telling us. Okay, Find the length of the radius of the circle to the nearest tenth of a centimeter. Okay, so one thing we have to know is that for this example, okay, so then, because what we're going to do is that we have a triangle in there, and so they just to explain in radians, I'm going to kind of explain degrees first, but we know that A plus B plus C, the angles, all add up to 180. It's a triangle. So we know angle A plus angle B plus angle C all equal 180. Well, if I just keep that in radians, that is the same thing as they all equal pi. Well, it's good that it's in radians because they tell me that ABC and BAC are pi over 6. Okay, so that's angle A and angle B. So this is pi over 6 plus pi over 6 plus angle C. So this is how we can figure out angle C. So now if you're asking, well, why are you doing this? Well, that's a good question. The question is because we need this angle. We have the arc length. We're trying to figure out the radius. So we're coming back to, again, A equals r theta. So we're trying to find r. We already have A, and we're trying to get the angle that makes A. And so we're trying to figure out angle C right now. And so to figure out angle C, we're just going to minus the pi over 6 over here to pi. So that's pi over 6 plus pi over 6 is 2 pi over 6, which is pi over 3. So it's going to be, if I do that work, 3 pi over 3 minus pi over 3. So that means that angle C is 2 pi over 3. Okay? So now by knowing that, we now have everything we need to execute our A equals r theta. So we have A, 15.2, equals, we don't know r, that's what we're solving for, equals 2 pi over 3. And we're simply just going to divide the 2 pi over 3, or solve for r here, so you can times the 3 if you want, divide the 2 pi. You calculate that there, and you're going to get the radius is 7.3 centimeters. Okay, and that's all for this one.